what I've done is I've pulled another board in place, and this is a little more developed and configured and ready to go, to kind of give you folks an idea of how this all fits back together. Anyway, let's just take this cover and set it to the side. Now, here's your new I/O card down here. Okay, and the cover has been put back in place and the screws tightened. So now you've got your original CPU taken out, and you've kept the I/O card, and you've put our new I/O board in there. And then the next thing, all that's been put back together, and your PLC's been snapped in place, and we have some wires already in place. The blue wires, the blue, solid blue, are basically related to 24-volt DC signals. The blue and white wires, the blue wire with the white stripe, and sometimes you'll find white wire with a blue stripe, but that's going to be related to your commons or your neutrals that are going to go into each system. This is where you're going to need the original set of schematics that we mentioned earlier, and especially that first page, okay? And this basically shows the CPU card, and I've highlighted all the different signals that we're trying to locate for you, showing you where they all go and connect up to. For example, this blue wire that comes out of the PLC over here on the 24-volt DC side, it goes right down here, if you'll trace down there, to an input called 24 volt, okay? And that's we find that on the card. And then the next thing we want to do is we want to hook up this striped wire, and we're going to take it all the way down to the bottom of the card, and we're going to find a connection called P ground, PGND, and that's our power ground, okay? So each one of these that are labeled on this row here are found on this card in various locations throughout the card. So you may have to look around a little bit, but it's easy enough to find these inputs and these outputs. Then the next thing we get to is we want to look at the commons, okay, on the digital I/O. And there's actually two sets of commons. There's two on this side, and there's two on this other side of the terminal strip, okay? Those are all D grounds, or digital grounds, okay, D, G, and D. And so we go down on the board and we locate these guys right here. So here's your blue and white striped wires, and they go down and they connect up to digital grounds here, digital ground over here, and so on and so forth. So all that wire is terminated, and that's something that you'll be responsible for and that you'll have to do. And then the 24 volts that you find here, there are other 24 volt sources, terminal blocks found throughout the module. Now, if you want to get a little clearer picture of what that looks like, you can go to this page, the second page of the drawing, and it will indicate on here where your 24 volt DC connections are all located. It'll also show where your P grounds, your D grounds, and then also A ground, which is the analog ground. So anything that connects to an analog card has got an A, G, and D connection to it, or an A ground connection. So that's all found on the interface card right here, and that drawing does spell that out and lay that out in a little more detail for you. So anyway, once you've located those, then these wires are routed to those locations and then connected up. Now, one thing that's really handy to have when you're working with this, with these wires, is going to be a set of hemostats like this, very small set, that allow you to work in and out and around all the wiring that's going to take place on the PLC over here. And also, this screwdriver is a 2.5 millimeter by 50 millimeter type of screwdriver, and it's very small tip, and that's what you're going to have to get into these screws that are located along the I/O card. So you're going to have at a minimum a 2.5 millimeter width tip screwdriver, flat blade screwdriver that you'll have to work with. Now, what I've shown here basically is the wires as connected and where they terminate. Now, if you'll notice, I've also got labels on each one of these wires. And in the kit that we supply, we put two labels in here, one for one end of the wire and the other one for the PLC end of the wire. So you get your I/O card side and your PLC side. Now, this strip of information or labels basically are some of the more common titles and names that you're going to find. For example, oil pressure, oil temperature, motor current. So anyway, we've got all the way up through, I think, a typical 5-stage centrifugal air compressor. We've got labels for most of that. And then we've got some spares that we put in there, and we just call them spare 1, 2, 3, 4, and 5 that you can locate for other I/O that you've added or that you want to implement on the system. Now, we'll go through the programming at a later date, kind of show you how you can configure the programming such so that you can customize it to any kind of system out there for any kind of input or output that's on these boards. But anyway, to start out with, we've got the labels here, and we've also got a group of wires that covers all the connections. If you have a system that takes all the connections off of the I/O card and hook them up to the PLC, you've got enough wiring here to take care of that. Now these wires are all 14 inches long, and that's kind of why you might find some of these that are a little bit on the wadded up side there, or kind of a curvy side. It looks like you've got excess material. Now we've also supplied with this kit some tie wraps, some wire ties. So once you get everything put together, you can merely go in here and take your wire ties and group these wires together and tie it up and make it look a lot cleaner. Okay, so that's one of the some of the installation that's going to take place there. Now, each one of the analog cards is laid out on a third drawing. This is where you're going to start taking your CMC drawings and you're going to start writing in what signal goes into what input on the PLC. For example, if you want stage 1 temperature, okay, that goes into our connection IN7+ that's found on the card in slot 1. So this is slot 1, and if you look at our drawing here, indicates that this is slot 1, so that lines up with slot 1 there. Then we go over here to the drawing, we find slot 1, and we find stage 1 temperature is on input 7+. Okay, so we go over here to our CMC drawing, and what we can find is we can go over here and we can find, for example, in this example here, I think they have got air temperature stage 2 for, let's just use that as one of the first examples. So we go down here and we know that air temperature stage 2 is found on input 10+. Okay, so you go over here to your card and you locate IN10+ right here. So you know that stage 2 air temperature is always wired in on the TurboLogix in that fashion. So we go over here and we locate air temperature stage 2. We look for the signal wire and we find it on J1P16. Okay, so over here in your column that says to be filled in by the user, we go down there to input 10 and we write down the number J1P16 or J116. Now we can go over here to this board and we can look around and we're going to find a J116 on that I/O card. So we can connect up our input that's terminated here on the card here, and then we can run that up to input number 10 on the card here and make that connection. So that's very simple, very straightforward how to do this. It's all mechanical. There's no programming that's involved. Basically, you locate the input or the output on the card here, your CMC drawing, and then you write that number down in relationship to the input that you needed to terminate on. So for example, motor amps, we always know that motor amps terminates on J9-1, pin 1, J9 pin 1. Okay, always terminates on J9 pin 1, which is located in the back corner over here. So we always know that that goes on to our input 0, IN0+ is the termination here. And if you'll look at closer, you'll notice that we've put a name tag on there that says motor current, and then you go down here and we've placed that same name tag on the other end of the wire down here that says motor current. So we do know that that's the motor current wire and where that is connected up. So anyway, that's kind of the direction we're going with this whole wiring. Is the best thing for you to do is to locate all of your signal wires, line them up with whatever the TurboLogix I/O description is, and write that into that column. And then that will allow you to go up and figure out which input, as far as the analog input, that you wire to. And you'll take each one of these wires that we've got. They're about 14 inches long, so you've got plenty of termination room and area to work with. And you'll put that wire into that connector there, bring it all the way up to here. Now, before you do that, like we've mentioned before, we've got tags. So if you've got something, for example, in this example, air temperature stage 2, we've got a tag in here that says stage 2 temperature. So you can heat shrink that on one end of the wire, heat shrink it on the other, and then you can terminate it on the board up here, and then you can also go down to the I/O card and terminate it in the proper location. Now, if you're having issues trying to figure out where on this board in the CMC that we've placed in there, our new I/O card, where the inputs are located. If you'll go to I believe it's probably the second page of our drawings, we basically have located all the inputs and tied them back over to the terminal blocks. So all your analog inputs come over here and they terminate up on the top portion of the board in that location. If you look at your digital inputs, they terminate in a couple of different locations, one over in here and also down in this location. So you've got all these references that give you a way to tie together where you're going to be terminating, where you're going to locate. You can also cross over these inputs right here. For example, J1P16, you can go over here and you can look for J116 on our drawing and locate that, and you can highlight that with a yellow highlighter and make it a little easier for you to try to transition and make the wiring change from here, or the wiring transition from here up to the PLC. So anyway, that's the simplicity of the system, and it makes it very quick for you to change out and to configure a new CMC TurboLogix EV system, so that you can go and replace your old CMC control with a newer TurboLogix.